Welcome once again to my YouTube channel, and visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and you will find me there explaining pure mathematics from book 1 to 4. I will also be explaining international GCSE mathematics, and of course statistics 1 and mechanics 1 moving forward. But in this video, I would wish to continue with chapter number 6 or topic number 6, which is differentiation. And today I want to introduce something very, very important in the world of mathematics called the chain rule. And before we go to example 6, I would just want to say something to do with the chain rule. What is chain rule? Sometimes you will find some expressions or functions that are not as direct as you have always experienced. You are used to dy dx. You are used to have y to be a function of x. Let's just be simple. And the dy dx in this case is 1. But I just don't want to go back to fundamental differential of this function. I want to remind you, every time you have a function that is in terms of x, then it is very easy to find dy dx. But sometimes you will not find functions that are in this format. You will find some functions where y is a function of, let's say, u, where y is a function of u, and u is a function of x, or x raised to power whatever. It's a function of x in a different arrangement. Y is a function of u, and u is a function of x in a different arrangement. But then you see that you cannot have dy dx. It is not going to be as direct as it is, because we do not have a situation whereby y is equals to x itself. That one does not exist. So it is not easy to have dy dx. Is not easy because it's not direct. Y is not directly related to x, and therefore the dy dx is not going to be easy, is not going to be direct. But there's something which we can use, and we are calling it now the chain rule. At this point, we need to introduce the chain rule, whereby the dy dx, first of all, we have to deal with this function and have dy du multiplied by the differential of this du dx. And what have we done? If we have dy dx to be equal to dy du times du dx, and of course we cancel du and du, we are left with now what we intended to have in the beginning, dy dx. So it is true that the chain rule is dy dx, which is equals to dy du multiplied by du dx. This is what we are calling the first order chain rule. We will find some other format of chain rule, but this is it. We have to live with it. I've just explained, and I want us to use this one to explain example 6 on P3, page 128. Given that y is equals to 3x4 plus x, and everything is raised to power 5, find dy dx. There is something, okay, dy dx, of course, using chain chain rule. But I want you to look at it. It is very difficult and it will consume your time. If you would want to expand this bracket 5 times, you will waste your time. But chain rules make it very easy, because we are simply saying let u be 3x4 plus x, and therefore y becomes u raised to power 5, and dy du now becomes and this is exactly what we have. Let u, so we have dy du to be equals to 5u raised to power 4, the way we know it, and du dx. Now we have to arrest this expression and differentiate u with respect to x, which is going to be given by 12x3 plus 1. 12x power 3 plus 1. And I hope, let me repeat that. I don't think it was visible. Now, let u be equals to 3x power 4 plus x, this part. So the whole of this expression becomes y is equals to u raised to power 5, because this is now our u. So very easily, if you want to differentiate y with respect to u, dy du is simply 5u raised to power 4. You can see this. And again, if we got the u is equals 3x4 plus x, du dx becomes 12x power 3 plus 1. But now generally, dy dx becomes dy du times du dx. And what is this? Because eventually you can see the du and du should or would cancel out and left with dy dx, which is easily 5u raised to power 4 multiplied by 12, which is now du dx, 12x cubed plus 1. At that point, we need to remember what was our u, because in the original expression, we didn't have anything to do with u. So there is no way we can give our answer in terms of u. There was no u, then in our final answer, we do not expect u. And then we say, but u was 3x4 plus x. So what are we saying? Therefore, dy dx becomes is equals to 5, 3x4 plus x multiplied by 12x cubed plus 1. And that is just like the very final expression that is supposed to be to give us dy dx using the chain rule. Remember, we have to make inside the bracket to be u, and of course now use the chain rule as elaborated up there. So this is very, very critical and very important for you to note. Chain rule is a method of differentiation that simplifies work. Other than, I don't know how long it would have taken any one of us to expand this expression 5 times, so that we ignore u and only deal with the x. I don't know how long it would have taken. And even if it would have taken us, we would have been able to expand, I think the expression and all the steps would have been very vulnerable, because again, when we are expanding this in so many steps, then again, it is very easy to make careless mistakes, even when we are multiplying out the bracket. So use the chain rule instead of doing the donkey work of expanding that bracket 5 times. So visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. Subscribe and share widely, and of course like, and let us work together.